And Let's Talk Chemistry with Pastor Dan. We're looking at chemical reaction. Definition of chemical reaction is a process of chemical change. Now, remember at the beginning of the year, we talked the difference between chemical change and a physical change. A chemical change is one where a new substance is formed, and a physical change is where no new substance is formed. So, a reaction is a process that makes that take place where a new substance is formed. Now, when we have a reaction, there are two parts. We have reactants, we have products, and the little arrow in the middle here, we say yields. So reactants, yields, products. Now, reactants are defined as what starts a chemical reaction, substance that starts a chemical reaction. So we always begin with the reactants. That would mean then that products, the end of chemical reaction. So reactants begin, products end, yields in the middle. That's the process. Now, we have something we have to identify some values. So in this expression I have there, 3CO2, we have something called coefficient. That little 3 there is a coefficient. What that means is it identifies how many molecules I have. So I have CO2, carbon dioxide. I have 3 carbon dioxides here in this molecule. The other number we have is called a subscript. That's that little 2 right there. Subscript tells me how many of that element are in this molecule. So without that 3 there, if I take that 3 away, I would have 2 CO2s. But by putting that 3 out front, I now have 3 carbons and 6 oxygens that we're going to multiply through to identify the total number we have there. Now, when we balance reactions, they're a 4-step process that's easiest to do. First thing we do is balance all metals and semi-metals. Now remember the periodic chart. Right here. Good. All right. Those are the ones on the left side of that little line we put in there between metals and semi-metals and non-metals. So we start with those, balance all of those first. Then we're going to balance all non-metals except for hydrogen and oxygen. Third, we're going to balance hydrogens. And lastly, we're going to balance oxygens. If we've done it right, oxygens will either be balanced or quickly balanced after that. All right, let's take a look at some of these. So here's our first example. C3H8 plus O2 yields CO2 plus H2O. Propane plus oxygen gives us carbon dioxide and water. Now, are there any metals here? No, there are no metals here at all. So now we look for nonmetals that are not hydrogen and oxygen. That would be carbon. I have 3 carbons here. I have 1 carbon on the product side. So what number would we multiply by 1 to get 3? That would be 3. All right. Now we don't have any other nonmetals except for hydrogen and oxygen. So balance hydrogens. I have 8 and I have 2. So what number times 2 is 8? That would be 4. Now we check our oxygens. I have 2 on the reactant side. I have 3 times 2, that's 6. And 4 times 1, which is 4. 6 plus 4, that's 10. So what times 2 is 10? That would be 5. That reaction is balanced. All right, let's look at the next one. All right, so we do have a metal here, magnesium. We have 1 magnesium on the reactant side because there's no number there. We assume that that's 1. 1 over here as well. Nothing done yet. All right, next we look at nonmetals, hydrogen and oxygen. The only one has chlorine. Now that 2 applies through. So I have, without the 2 here, I have 1 C and 3 oxygens. Because that 2, I'm going to multiply everything. So I now have 2 C's and 6 oxygens. So I have 2 Cls, chlorines, and 2 Cls over here. So they're also balanced. Nothing interesting yet. So next we'll do oxygens. I have 6 oxygen, 3 times 2. Over here I have 2. So what number I multiply by 2 to make 6? That would be 3. That's balanced. All right. So I want 3 I want you to look at here. I'm going to go through them in a second. So pause the video. Try these 3 and then we'll walk them through together. Okay. So pause it. All right, let's see what we get for the answers here. So for the first one, barium, 1, we're cool. Another metal, copper, 2, and 1, so we put a 2 right there. All right, we now do iodines. So I have 2 iodines, and I have 3 iodines. Common multiple of 3 is 6. So put a 2 here, and a 3, well, 2 is already here. So put a 3 over here to balance that up. Now I mess my bariums up, so I got to put a 3 here. So now we have 3 bariums, and my oxygen's 3 and 3, they're already balanced. Now, There's another way of doing these if you want to. If you look at these down here, these are polyatomics. You remember PO4 inside the box, O4s are 8, so that's phosphate, and it's still phosphate over here. And then we have NO3 ends outside the box, O3s and 8, so that's nitrate, still nitrate over here. So we could keep these together if you want to. If you don't want to and want to do metals, non-metal, hydrogen, oxygen, same way we're doing, that's fine. Let's try this. We have 3 silvers, 1 silver. We can start by putting a 3 over here. We got 1 magnesium, 3 magnesium, put a 3 over here. Let's do phosphates. I've got 1 phosphate, I've got 2 phosphates. So put over here, that changes that to 6. So this becomes 6 now. I now have 6 nitrates, NO3s. I have 2 times 3, 6 nitrates. That's balanced. Now we could do all the oxygens if you end up. I think you end up with 24 oxygens at the end there. All right, this last one. 1 Al, 1 Al. We're good. Then P, 1P, 1P. What I do in my class to make sure that you're not just skipping over it, if you think it's balanced as is, where is, write the letters BAL, period down. That shows that you think that's balanced as is, where is. All right, let's try some more practice. Now, I'm going to do the first one with you. Then I want you to do the rest of these, so copy these down and work them through. All right, let's do the first one together. Oh, we'll put a little slide up there so we can cover these up. All right. Now, when we do this, we end up with 2 carbons and 1 carbon. So we start with 2 here and a 3 here. Now, this is what I call an odds and even situation. I'm going to end up with 6 and 3, that's 7 and 2. That's not going to ever balance. So we got to identify which one's causing the problem. Where do we get this 2 and 3 from? Well, we got the 2 and 3 from C2H6, ethene. All right, so I'm going to double it. When I do, I double the carbon dioxide to make it 4, double the water to make it 6. I now have 8 plus 6, that's 14 oxygens. We need to go back, put a 2 oxygens here times 2, that's 7. Good to go. Okay, so let's go back and try the rest of those on your own, okay? And then we'll go through here in a second. All right? Give it a shot. All right, here we go. Those are the answers. And again, down here, this is another odds and even situation. So this one's the one that's messing me up. I double this one up. And I should also put a 2 right there. Oop, 2 right there. And make it a little bit longer. So we got space for all of them in there. There we go. That's proper. All right. Hopefully that wasn't too bad. Take care. Be good. God bless. Bye.